A university wants to find out the IQ of their freshman class. We know that the average person's IQ is 100 with a population standard deviation of 15. They obtained an SRS from their college of 50 students out of the 5,000 that go there, and the mean IQ of this group was on 112. Now, what can this university say about the mean IQ of their freshman class? Now, what we would do in previous chapters is we do a hypothesis test. We know the mean is 100. We can write the hypotheses, check the conditions, make sure they work, do some calculations and find a z-score and a p-value. And then we reject the null hypothesis because the p-value is low. We have evidence that the university students is greater than the average American IQ, which is great. But we really don't care about that because we would assume that somebody going to college will have a slightly higher IQ than the average American population. So that shouldn't be the concern of the university. The concern of the university is what is that mean of the students. So what we want to do is we want to say what can we say about the population when we only have a sample. We only have data from 50 students. What can we say about where that population mean is? Also, where is the true mean for all college students at the college? So those are the big questions that confidence intervals start to answer. In order to do this, what we do have to do is we have to assume that the mean of the sampling distribution of x bar is the same as the unknown true mean mu. And we know that the standard deviation for the population is 15. So then the standard deviation for the sample is 2.1. And how we get that? We take 15 divided by the square root of 50. Now the central limit theorem tells us, since we have 50, that this is going to be close to a normal distribution. So we want to estimate mu the best we can. We can use our x bar from our random sample. We call this a point estimate. They use this word quite a bit, so just make sure you know the word point estimate is what our x bar is. You know what it is, it's just a new name for it. Now x bar is probably not equal to mu. So we have a population out here, mu, and we just took one sample from it. We don't know if it's on this side or this side, but we know it's somewhere. So let's say we take an x bar and it's here. It's probably not the true mean. If I take repeated samples, though, of x bar, it will follow this normal distribution with a standard deviation of 2.1. The downside is we don't get to take repeated samples. We just have our one sample. So about 95% of the data is within 2 standard deviations of the mean. So from here to here, that's going to be about 95% of the data. 2 standard deviations below to 2 standard deviations above. So what we can do is 2 standard deviations is 2 times 2.1 is 4.2. And so we'll assume wherever x bar is within 4.2 standard deviations of mu, mu is within 4.2 points of x bar. So that unknown mu lies between 4.2 taken from x bar and 4.2 added to x bar in about 95% of the samples that you can take from the population. So we estimate that the true mu lies between 107.8 and 116.2, and we're 95% confident of that. So we would be calculating this interval using a method that captures the true mean 95% of the time. So we're 95% confident that the true mean is in those values. So when we're doing a confidence interval, like we just did there, we have an interval and we have the confidence level. So for the interval, we have our estimate, and sometimes it's called our point estimate. Sometimes it's going to be x bar, sometimes it's going to be p hat, sometimes you're going to subtract some values, sometimes it's going to be slope, and you add and subtract it to the margin of error. In our case there, our margin of error was 4.2. And we're going to talk more about your margin of error. Now the confidence level, C, in that case, our confidence level was 95%. That gives the probability that the interval will capture the true parameter in repeated samples. So if you keep repeating, if you repeatedly took samples instead of just taking one, we would capture that true mean the confidence level percentage of times.